All right. So, we are learning how to read the abacus. We'll do that one over here. Hello, everybody. Welcome. So, we have our number. We're going to be doing this. And I need to find... I don't have it. Where did it go? Where did it go? How could I lose it? Oh, here it is. All right. Hello, everybody. We are reading the abacus. This is what this is. Hello. So, anytime the beads are touching the horizontal bar, it is considered counted. So we have a 3-digit number. This is a 3-digit number. We have the 6, 5, plus 1 is equal to 6. We have 7. That's what 7 looks like. 5 plus 2 is 7. And then 8. 5 plus 3 is 8. Hello, Beans! Hello, Beans! How's it going? How's it going?
Welcome to the real world.
Welcome, welcome, welcome. How's it going? Not too bad, yeah? You alright? Okay, so it's 687. There we go. And then we have our next number. That's 687. And then we have our next number. Okay, there we go. I don't like to explain. Kleptomaniacs. Why would you have to explain puns to kleptomaniacs? That's very interesting because they. That's funny. That's funny. All right. So, we have our next number. Let's try that. There we go. So our next number is, we have our 4, 2, and then 1. So we have 421. You always made me saw, so I had to... Thank you. Thank you, Beans. I appreciate that. We have 421. And we have our next number. So that's 421. And then we have this number. This is a 3-digit number. When we're looking, we have the ones over here. We have the tens, and we have the hundreds. We have 1 over here, the hundreds, the hundreds, the tens, and the ones. What number do we have? So, for those of you that are interested, go ahead and put in the comment what number you think this is. We have 1. This is 5 plus 4 is equal to 9. And then this is 4. Hello, Duncan. Hello. Welcome. Welcome, Duncan. So it's a 3-digit number. It's not 21. It's a 3-digit number. This is 1. This is 9. This is 4. 194. That's what that is. And then 194 looks like that. And then we have our next number. Excuse me. So we have our hundreds. We have our hundreds. The top beat is a value of 5. The bottom beat is a value of 1. Together, this makes 7. We have 1. Notice that the top beat is not touching, so this is 1. If it was touching, this would be 6. This number would be 6, but this is 1. So this is 710 right now. And if I have another number, this would be 717. 717. So when we're looking, the top beat is a value of 5. The bottom beat's a value of 1. Thank you, Beans. Yes, thank you, Shannon, for the follow. So we're looking at 717. That's what the number looks like. Thank you, Crow, for the follow. Thank you, Alyssa, for the follow. 717. So what we're doing is we're learning how to read the abacus. Oh, look. When you see, none of the beads are touching the horizontal bar. So that is what it is. So we have 2, 3, 2. Yes, Crow. What? Oh, thank you, Evie. Yes. Thank you. I need to find my... Where did it go? Oh, here it is. You're right. Every column is a place value. We have our ones, our tens, hundreds, thousands, and 10,000s. Thank you, Beans. Yes, it is 232. Thank you, Crow. Does that make sense? Now you might be wondering, why am I here? Because I have a label. That label tells me this is the ones place. And then notice I have a second label. This is the thousands. Just like the comma, it's like a readability. So when we're looking, this is the ones, the tens, the thousands, the hundreds, and the 10,000s. Thank you, Yellow Cake. I heart yellow cake. Thank you so much. Thank you so much. We have 2 decimal places. We do. Thank you so much, Beans. Yes, there are 2 decimal places. If we choose this one over here, if we choose this one over here to be my ones place, then we only have 2 decimal places. However, if I decide to choose this one to be my ones place, like a Pokemon,
I choose you!
then I move everything over, and then this would be the ones place. And then I'd have this whole row to be my decimal. So if I use this one to be my ones place, like over here, then we could do 0.00001. Hello, little Mellow. Hello. Thank you. And your... Oh, wait. Who? I've always wanted to learn how... Crow. That's funny. And your glow. Thank you. We can have 5. Yes, we can have 5. We can do 5. We can do 0.00005. You could do that. Or are you talking about this one? So if we move it back to here, right? If we move our ones back to here, we would do this. We would have ones, tens, hundreds, thousands, 10,000s. And then if we did this one, it would be 3,456. That's what that would be. Remember the comma? The comma is for readability. Oh, 5 decimal places. Yes, you're right. You're right. It would be 5 decimal places. Let's go back to here, right? We have 3,456. And then we can make it, we can extend it, right? We can have 73,456.25. So we go back to 2 decimal places. Are you from Cali in SF? No. I am in Cali as in LA. Sorry for the... Oh, no worries. So, can we use these for... I'm sorry. Can we use these for a math problem? Yes. We can figure out how to do a math problem. This number here is 55,000.
55 burgers, 55 fries, 55 tacos, 55 pies, 55 cokes, 55 wings, 55 shakes, 55 pancakes, 55 pasta, 55 peppers, and 155 taters.
So this is 55,555.55. That's what that is. So right now, Beans, just so you know, what we're doing is we need to understand how to read the abacus. Once we understand how to read the abacus, then we will go into understanding how to add and subtract. Yep. Great. Oh, great, grannies. Great. I've got my calculator. That's awesome. Hello, Serbio. Welcome. Welcome, welcome, welcome. Thank you so much, grannies, for checking in. Thank you so much. For those of you that are interested, go ahead and check in into the orange heart me that's above my name. That's to show TikTok that you are a real person. You want to show me your calculator? How are you going to show me your calculator? I have a lot of... How are you going to show me your calculator? I don't know how to do that. I want to show you. Okay. Okay, so then if I did this one, right, we could do a whole row of 6s, right? We could do a whole row of 8s. Oh, there you go. Hi. Wait, hold on. There we go.
Hello?
Hi.
Hi! I found them. I had to show you.
Oh, yay!
Alexa, turn the master bedroom lights 100%. So I think this one I had when I was a kid.
Oh, nice.
And then I think when we went back to Japan, I got this one too.
Oh, the Chinese abacus.
Is that different?
Yeah, because it's two beads on top, right?
Uh-huh.
Yeah. Oh, there we go. Yeah, two beads on top. Yep, two
So
beads
what
on
is
top
that?
is the
How do you
Chinese
count that?
abacus. Huh?
Is 10?
Yeah,
Is
that's
10?
10. Uh-huh.
Mm. Oh, cool.
Yep.
Do you teach that as well?
Nope.
No.
Nope. I only
Is that?
teach I only teach the Japanese abacus.
Ah, okay. Well, that's this one then.
Yes. Yes, it is.
Yeah, these are so old. They're like from the antique stores in Japan I went to.
Yeah, that's cool.
Yeah, but I thank you for letting me show you.
Yeah, not a problem.
I want to get my grandson to start learning how to do it. I've been meaning to message you, but I've just found him, so I'm
Good.
gonna be messaging.
Good. Sounds good.
Thank you. Thank
Sure.
you. Okay, bye.
Bye. Well, that was fun. Thank you. Thank you, 300 for the heart me. Thank you, Allie, for the heart me. Please tell us the best way we can support you. I don't know, Beans. I don't know. I appreciate everything. Thank you, 300. Thank you, 300. I don't know. I'm still trying to figure out. Thank you, Allie, for the awesome. And thank you so much. Ah, you guys are awesome. Thank you so much for the tiny tiny. Oh, yeah. Okay. I'm gonna do that. I'm not sure, Beans, like how it all works at TikTok. I'm still trying to figure it out. Can I send you Can I send you the Chinese one? No, because I already have a Chinese one. I don't need more. I don't need more stuff. Hello, Allie. Hello again. Hello again. So the Chinese one is very similar. We're going to review this similar. Yeah, it would be deco. Yeah. So we have one, two. You know what? Actually, grannies, you could do multiplication kind of 6 times table. So I'm going to use this as a counter. This is 1. I want to add the 6, right? We have 2, add the 6. Notice there's 2, this is 10, and then this is 1. Oh, maybe I should do this, right? So this is 12. Add another, so we have 12. 2 times 3, 6 times 3 is 18. We have 1 and we have 3. Make sense? And then we have 6 times 4. 6 times 4, add another 6. So we have 20. So this is a 10. So trade this into here. This is 24. 6 times 5, right? 5. 6 times 5 is 30. We have 5 plus 5 is equal to 10. So we can do that. And then 6 times 6, that's what 6 is. 6 times 6 is 36. 6 times 7 is 42. 40. So there's a 10 here. And do that. And then we have 42. And then 6 times 8 is 48. And then we have 6 times 9. This is 9. 6 times 9, you add another 6. And then we get 10, right? So this is 54. Yeah, I knew if you were so confused, but interesting to watch. Oh, hello. Oh, not a problem. So, Allie, we're going to do a review on the Japanese abacus, just so you know. Hello, Brandon. When we're looking, we have 1. Anytime the beads is touching this horizontal bar, this is considered 1. This is 2, right? 1, 2. We have 3, 1, 2, 3, and then 4. Anytime the beads are touching the horizontal bar, it's counted. This is 4. 1, 1, 1, 1. There's 4 ones. This is considered 4. So then, hello, burly boy. And then notice these are all zeros. We have 5. The top bead will always be 5, no matter what. The top bead is always 5. And then we have 6. 5 plus 1 is 6. And then we have 7. 5 plus 2 is 7. We have 8. 5 plus 3 is 8. 5 plus 3 is 8. And then 9. 5 plus 4 is 9. Does that make sense? Yes, the top beat is always, yes, the top beat is always 5. So if I did this, it would be that.
55 burgers, 55 fries, 55 tacos, 55 pies, 55 cokes, 55 wings, 55 shakes, 55 pancakes, 55 pasta, 55 peppers, and 155 taters.
When the 10 times abacus work the same, no, you would have to do modifications on the 10 by 10.
You need modifications! Modify!
Burly boy, do you have the 10 by 10 with you, or is this just theoretical? Because I can show you how to modify it. If you want to make it mimic the abacus, mimic the soroban, it is up to you. No, I'm talking, yeah, the one that your teacher had, yeah. The one that your teacher had is a 1-to-1. So when your teacher had it, it was every one has its own number. So it'd be 1, oh my gosh, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. That's what that would be. And it's a 1-to-1. Whereas in abacus, the Japanese abacus, we're actually using formulas. So these are the formulas we're going to be learning. And that's what I'm going to teach you. Oh, so for those of you that are interested, I do have this book available in my TikTok shop. That one. Well, that's what we're going to do right now. So let's do that. We have that one. So then our next number is this. Okay, what number do we think this is? So they give you a little basic, right? So we have our hundreds, nope, our hundreds, our tens, and our ones. What number do we think that is? Yeah. We have hundreds, tens, and ones. What number do we think that is? Thank you, Burly Boy. It is 341. Thank you, Alevela. When we're looking, we have 3. 1, 1, 1. There's 3 ones, 4 ones. 1, 1, 1, 1. There's 4 ones, and then 1. So this is 341. Well done. Thank you, follow. Thank you, 4454 for the follow. Ha! I'm good at math. You are good at math. Everybody can math. Right? What we're doing is we're learning how to read the beats, and we're going to learn how to read, and then we'll do some adding and subtracting. So we have our hundreds, we have our tens, and we have our ones. What number do we think that is? Hello, Dilly Dally. That's funny. That's a cute name. All right. So we have our hundreds, our tens, and our ones. Thank you, Bill, for the follow. The top beat is a value of 5. The bottom beat is a value of 1. The top beat is a value of 5. The bottom beat is a value of 1. I don't know if you guys are cheating. The top beat is a value of 5. So 5 plus 3 is equal to 8. So it's 8, 1, 8. Thank you. Thank you, 4454. Almost TT Destroyer. Almost. Thank you, Burly Boy. We have 8, 1, 8. So we have the top beat is a value of 5. When the top beat is not touching, then this is considered 1. The top beat is touching, this is considered 6. Because we have 5 plus 1 is equal to 6. This one is 5 plus 3 is equal to 8. So we have 5 plus 3 is equal to 8. So we have 818. That's what that number is. And we have our next number. Our next number is for user 1679.
Do you understand the words that are coming out of my mouth? Do you understand the words that are coming out from my mouth?
I just mentioned, this is the bottom beat, this is 2. I have this number. The top beat is a value of 5. And then this number here, the bottom beat is a value of 1. So there's 2 here, there's 3 here, there's 1 here. This is not 1, this is 5. So it's 2. Thank you, TT. It is 2, 5, 3. 253. Well done. So we have our ones, our tens, and our hundreds. So we have our next number. We have our hundreds, our tens, and our ones. Notice the top bead is touching the horizontal bar, and then these bottom beads are touching the horizontal bar. So when they're together like this is 9. Thank you, TT Destroyer. This is 8. 5 plus 3 is 8, and then we have 7. 5 plus 2 is 7. Thank you, Burly Boy. So we have 987. Notice that all the beads are touching the horizontal bar. There's only one that is not. They look very similar, but the difference is the one bead. This one is 2 beads are not touching. So this is 7, this is 8, and then this is 9. So we have that number, 987. 987 takes you to this number over here. So what we're doing is we're doing a maze. This maze, what we're trying to do is understand how to read the abacus. The abacus is a math tool. This math tool will help you visualize your numbers. The biggest thing on the abacus is understanding how to read it. Once you know how to read it, then we'll go into understanding how to move the beads. Thank you, Burly Boy. It is 700. Thank you, TT Destroyer. We have 700 and then 12. 1 and a 2. Thank you so much for... Hello, Carlos. How are you feeling? Thank you so much for the tiny diny. Yes, 712. Thank you, Carter and Burly Boy. We have 712, and then we have our next number. We have our hundreds, our tens, and our ones. What number do we have? Don't forget, the top bead is a value of 5. The bottom bead is a value of 1. So all of these ones, there's 4 ones. This is considered 9. Almost. Almost. We have 40 here, and then we have 5 here. I don't know if anybody's cheating over here. Because it's the same number. Can you explain it real quick? Hold on, Bobby. Yes, thank you, Burly Boy. We have the 945. So we have the top bead is a value of 5. The bottom bead's a value of 1. So we have 4 ones here. Together, anytime the beads are touching the horizontal bar, they're considered counted. So we have 9, 4, 5. The top bead will always be a value of 5. Thank you, Bobby Toe, for the follow. So when we're looking, we have 945. That's what that is. So 945, and we have our final answer. How are we doing? So we have our hundreds, tens, and ones. So there's 3 of them here. Thank you, Carter. Thank you, Burly Boy. We have 3 here, 2 here, and then 4. 324. That's it. So that is the maze that we just did. The maze is to explain how to read the abacus. In the beginning of the book, I give you an explanation on how to use it. And then we start going into, we start first talking about the single digits. Then we talk about the double digits, and then after the double digits. So here, I'm showing you what a double digit would look like. So this is 36. Remember, 30 is the tens and 6 is the ones. So when we're looking, this is 30, this is 6. Oh, yeah. Oh, good, Bobby. So, and then we have the triple digit. This is a triple digit. So if I had this number here, we had 824. So on the abacus, we do 824. And so we have our hundreds, our tens, and our ones. Notice that we have a label right here. This label tells me that this is my ones place. So this is what the maze would look like, and it is your job to color in the abacus and then find the path to get to the end. The problem is you're able to see the answer because the answers are on the path, right? So what I do is I give you the opportunity to use a mask maze. If you don't like the paper that it comes with, I do provide you a downloadable one. You just have to download it, and you can print it on any sort of paper that you like. I used a file folder. You can use some sort of cardstock or even construction paper. There's another type I have. It's called the reverse maze, whereas I give you the number, I give you the path, and then you're supposed to color in the number. So this is 780, so 780 goes over here, 780. And then I give you answers in the back of the book. That's it. That is my That's my book. Oh, excuse me. Okay, that's my book. So, for those of you that are interested, I do have this one available in my TikTok shop. I do have other books available in my TikTok shop or over here if you don't like the TikTok shop. These are all my books. I have been publishing, I've been teaching Abacus for about 20 years, and now I have 14 books available for you to consume. If you're interested for this one, I do have, if this was too much, I do have a 2-digit number. So if you're looking for children that are grade 1, grade 2, they're working with their tens place, then this would be perfect for them, because we just talked about the 2 places, right? They go up to what, 99, right? And so this would be 16. We have the 1 and we have the 6, and then you have to find the path, and it's the same, right? And then again we have the mask maze. We have the reverse maze. You find the number and you color in the thing. So I hear there are exercises to help improve Abacus performance. Ha ha ha! Ah, that's funny. If you're interested, I do have a 4-digit puzzle. And the 4-digit is exactly what it sounds like. It is talking about 4 digits. We're talking about the thousands, the hundreds, the tens, and the ones. So if we were looking at this one, this is what a finished Abacus, finished maze would look like. I do give you the mask maze, and we start reviewing all the other numbers. So instead, let's figure out what this number is. What number do you think that is? Excuse me. Sorry. It's been a long day. So what number do you think that is? We have our thousands, our tens, our ones, and our tens and our ones. What number do you think that is? I've been talking to all the men in the chat. You suffer from limp abacus syndrome? Are you sure, or the pulverizing abacus? Thank you, TT Destroyer. Yes, it is 7,772. That's what that is. And so you would find the answer, 7,772. And then you take you to this number over here. What's our next number? So again, what we're doing is we're doing the 4-digit number. We have our hundreds. We have our thousands. We have our hundreds. We have our tens, and then we have our ones. What number? Almost, Burly Boy. It's the other way. Excuse me. What number do we think that is? Let's see if we can. Yep, there we go. So for those of you that are interested, I do have this book available in my shop. It is this one. If you don't like the TikTok shop, I do have it available over here. My name is Lynette. Thank you so much. Hello, Michael. Hello, Michael. Good evening. 4,954. Well done. So when we're looking, we want to separate the two. Thank you, Burly Boy. No, not 9. 5. Right? 4,954. I don't know if this is going to be the shortest live because I can't stop yawning. Okay. Let's see. How are we doing? All right. So that's this book. And then again, we do have the mask maze. We do have the reverse maze. That's what this is. And then notice that you find the number. You're given the path. It is your job to color in the abacus. I think I need to exercise my abacus. I was in the pool. If you're in the pool, was the water cold? All right. We're going to continue on. Thank you for the follow, Unlucky Seagull. So this is the other book. This is my preschool abacus. I was trying to get them young. I was trying to get them... I see that you got my... This book was meant for ages 3, 4, and 5. For those kids that don't understand their numbers, that's what this was for. Or, or if you're wanting to start off, if you want to start off in a different path. of understanding the abacus. This is mostly just understanding what the numbers are. Just regular numbers, right? So we're looking at the numbers. We start off with 1, or no, we start off with 0. We always start with 0 because on our abacus, what we do is we always have to reset our abacus. So we always know that this is 0. This is not a new concept for the kids. The kids will know that this is always going to be 0. So then we talk about 1, 2, 3, 4, and then we have like tracing and then the number and then more tracing and then the number and then trying to correlate the numbers with the abacus and the other objects. So I give you activities, and then we start doing the 9 to 5, and then again it's the tracing and the finding in the abacus, and it's the tracing, and then more activities. I give you pixel art. There's also some cutting, and then after that we talk about counting forwards. After counting forwards, we count backwards. After counting backwards, we figure out what number comes in between, and then after that we figure out what the numbers are surrounding, and then we do a comparison. Which one's bigger, which one's smaller, and then we start going into adding and subtracting. All right, Burly Boy, I'll see you in a little bit. Can you add the numbers? That's what we're going to do right now. So in Abacus World, what we're going to do is we're going to understand how to move the beads. We're going to understand that. We're going to look at the second number. We don't need to look at the first. We don't need to look at the last, because the number, the answer will appear on the abacus like magic. So we have 7 on the abacus. Let me do numbers instead, right? We have 7 on the abacus like this. 7 on the abacus. I want to add the 1. When I add the 1, do I have enough? Can I do it? Yes, I can. So I just need to add the 1. So my final answer is 8. All right. And we could do it again with the 6. Again, do it again with the 2. What is 2? 2 is 2 beads. That's what 2 is. But if I have 6 already on the abacus, all I need to do is move the 2 beads up. When we're adding, we go to the horizontal bar. When we're subtracting, we go away from the horizontal bar. So if I want to subtract 1 from the number 8, I just move it away like that. So it's not a separate concept. It's just the inverse. And what we're trying to do is we're trying to understand and show the kids that if they know how to add, they know how to subtract. You go to the horizontal bar to add. You go away from the horizontal bar to subtract. So they actually understand this, as opposed to in mainstream math, they're like kind of confused of like what subtraction is, because it's a lot of words that they're being thrown at. But in Abacus, we actually show you. So here, you could do the dots, or you could do the tally marks. What we're doing is we're understanding how to add the 3. To add the 3 on the Abacus, all you got to do is move it towards the horizontal bar. I have 5 on the Abacus. I'm only adding 3. So my final answer is 8. We can actually scale it. We can say 50 plus 30 is equal to 80. We can even say 500 plus 300 is equal to 800. Hello! Hello! Pendo. No, not Pendo. Cami. Hello, Cami. So, does that make sense? I think I'm going to have to end this pretty early. I am really sleepy. All right. So, what we're going to do, thank you so much for checking in. We're going to do add the 4. Thank you, Michael. Haha. We want to add the 4. So notice if I have the 5 on the abacus already, I am going to add the 4. I'm going to add the 4. Add the 4. This is all the bottom beads. So my final answer is 9. Yeah. And then, if you know how to add, you know how to subtract. If I have 6 on the abacus, right, I want to take away 1. That's what this is, right? We're going to take away the 1. It's not a negative 1. It's a subtraction of the 1. So we take away the 1. And we can do it again. Here is 2. So 2 is what? There's 3 on the abacus. I want to take away 2. So my final answer is 1. And then we could do it again. We have the 4 and the minus 4 and then the 5. So now the 5 is adding of the 5. We have 3 on the abacus. We want to add the 5. My final answer is 8. And because you know how to add, you know how to subtract. So if we have 9 on the abacus, I want to subtract 5. You just take it away like that. Hello, Tax! I clicked in before I heading to sleep. Okay, thank you, Michael. Thank you, Michael, for joining. She is the most dedicated. Thank you so much, Tax. Yes. But I think I am going to end the live pretty soon because I just got tired. I can't stop yawning. All right, so we're going to continue on a little bit more, but thank you so much. Thank you so much. I do appreciate it. We're doing 6. Okay, yeah. So 6 is 1 beat on top, 1 beat on bottom. That's what 6 is. But if I already have 2 on the abacus, I want to add 6. To add the 6 is 1 beat on top, 1 beat on bottom, and you bring it together. Can you add and subtract by 10? Yes, you can. So if I add the 10, take away the 10. That's it. Add the 10, it is now 18. And then we can do 20, 38, 48. And then we have 58, 68, 78, 88, 98. Did that make sense? So, because you know how to add, you know how to subtract. You just take it away like that. So this is 92. So right now we're at 92. And we can do it again with the 7. Notice, in Abacus world, we don't need to memorize how to make a 9, right? How do you get 10 to start? 10 looks like that. 10 is a 1 and a 0, just like how you write it. 10 is a 1 and a 0. 0 is here, 10's over here. This is my ones place. This ones place tells me that this is where the ones will be. So we have ones, tens, hundreds, thousands, 10,000. And then this is actually the decimals. This is the tenths, and this is the hundreds. That's what that is. So in Abacus world, we don't need to memorize how to make a 9. But in mainstream, they want you to memorize. Thank you. I am divine for the heart me. Thank you so much for checking in. I see that. I see that. Oh, and then Michael. Okay. So notice if I have 1 on the abacus, I want to add the 8. Notice I have 8. 5 plus 3 is equal to 8. You bring it together. That's what 8. So this is the final answer is 9. So what I'm trying to show you is that we don't need to memorize how to make a 9 on the abacus because the 9 already shows. So if I have 2 on the abacus, I want to add the 9. I'm sorry, I want to add the 7. So if I add the 7, it becomes a 9. We don't need to memorize it because it just tells us what we have. So even if we had 3 on the abacus, that's what 3 on the abacus would look like. And then what? We want to add the 6. Adding the 6 is 1 beat on top, 1 beat on the bottom, and it brings it together. So that is 9. Okay. And then we have our final answer. We have 100. I'm sorry, we have 4. And then plus the 5 is now 9. So we don't need to. Hello, Scarface. Hello, Scarface. I just saw you. How are you doing today? I'm a little sleepy. I think I'm actually going to turn off the live pretty soon. I just got tired. It's like a 10:44. Yeah. How are you doing? It's been a little bit. How are you doing? Do you have bubble gum?
I have come here to chew bubblegum and kick ass. And I'm all out of bubblegum.
Hello, one word. Hello. So again, we're going to we add the 9. When we add the 9, we want to take away the 5. To take away the 5, we just move it away like that. Thank you for the follow. Thank you for the follow, Dime, and one word. So our final answer is 4. We can do it again. Now, if you notice, what is 6? 6 is 1 beat on top, 1 beat on the bottom. If I have 9 on the abacus, I want to take away 6. Take away 6 is 1 beat on top, 1 beat on the bottom. You take it away like that. So my final answer is 3. Thanks for asking. Yes, I do have bubblegum. Guess what we're doing today, Scarface?
Gee, Ray, what do you want to do tonight?
The same thing we do every night, Pinky. Try to take over the world.
That's what I'm trying to do. That is what I'm trying to do. But I don't know if I can do it tonight. All right, so that's how you minus a 6. And again, it's the same thing with the 7. If I have 9 on the abacus, I want to take away 7. Take away 7 is 1 beat on top and 2 beats on the bottom. So my final answer is 2. And then it is the same thing with the 8. So if I have 9 on the abacus, I want to take away 8. 8 is 1 beat on top, 3 beats on the bottom, and you push it apart like that. So that becomes 1. So 9, take away 8 is 1. Learning every day, and all day. That's great. Always keep learning, Scarface. Always keep learning. It makes us a better person as we learn. So our 9 is the same. 9 is it's there's nothing to the 9. You add the 9, you take away the 9. You add the 9, take away the 9. That's it. All right. So we'll do a concept, and then I'm going to turn in. The concept is, how do you make a 5? One of the things is a core concept that in math in general is we teach the kids how to make a 5. In Abacus world, we actually utilize the 5. So here is 4 plus 4. 4 plus 4, I know you know, it is we all memorized it. I know, we know our doubles. But let me show you another way why we need to know formulas, right? We need to understand how to make a 5. How do you make a 5? We know 5 is 4 plus 1 is equal to 5. I want to add another 4. Mainstream, what do they say? Well, you just count up, right? 4, 5, 6, 7, 8. So that's what that is. However, in Abacus world, we know this concept. We know 1 plus 4 is equal to 5. What does that mean? Well, notice, here it is. Notice we have 4 on the top bead. That's 4. 4 is on the abacus. I want to add another 4. I cannot add 4 to here because that would just be 44. What we want to do is we want to add 4 to the ones column. Because we add 4 to the ones column, how are we going to do it? Well, this is where we need to make a 5. If we want to add the 4 to here, we got to make a 5. What do we do? Well, notice 4 plus 1 is equal to 5. 4 plus 1 is equal to 5. So we take away 1. We take away the 1 from the previous number. You got to give it away. So we take this 1 and we add it to the bottom 4, and now I've made, and I can round it up to 5. So I have to add the 5, take away the 1, and my final answer is 8. 5 plus 3 is 8. Hello, yes man. While learning while working. Good luck. Good luck. But I just want to let you know I'm going to turn in pretty soon. I am really tired. So we could do it again. Thank you, Aurora, for the follow. We can do it again. So now what we're going to do is we're going to solidify the concept. We had to subtract in order to add. Thank you, Mark, for the follow. We had to, just like in drifting.
If you're going hard enough left, you'll find yourself turning right.
Oh, right. That makes perfect sense. Turn right to go left.
That makes perfect sense. You have to go right to turn left. So what did we do? We actually had to take away 1. Why? Because our 4 is right here. Because we have 3 on the abacus, I have no more room to add the 4. Guess what? To make a 5 out of the 4, what do? We got to take away from the 3. Take 1 away from the 3 and you add it to the 4. Now I round it to make a 5. So my final answer is 5 plus 2 is equal to 7. I want to do this. Does that make sense? So we're going to continue on because we have a whole set. The whole set is this. If we know 4, we can do 3, 2, and then 1. I gotta start over. All right. So that's why we do 5 plus 1 is equal to, 4 plus 1 is equal to 5. The 4 is making a 1. We could do it again. We have 2 on the abacus, right? If we have 2 on the abacus, there's 2. Here is my 2. What are we going to do? We want to add 4. Did it again. Add 4. But notice, I don't have any more room to add the 4. There's no more room to add the 4. What do? I have to take away 1 from the previous number. So take away 1 from the previous number, and then you add it to the bottom number. That becomes 5, like this. So my final answer is 6. 5 plus 1 is 6. So you add the top bead to make it a 5. So 5 plus 1 is 6. Okay, there we go. There we go. Hello, Robert. Robert. Hello, Robert. Just in time. I was actually going to sign off pretty soon. I just got tired. I was like kind of struggling a little bit. So we have our next one. You all right? How'd your live go? How many problems did you go through, Robert? So we have 1 on the abacus. I have 4. I want to add 4. To add the 4, guess what? There's not enough room to add the 4. Hello. Hello, Sir Devious. Do the rows on the abacus mean anything? The rows is a row. This is a row. These are all ones. That's what that means. Are you talking about columns? Columns, every column is a representing of a place value. So we have our ones, tens, hundreds, thousands, 10,000s. And then every number is represented. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then if you notice, we could do it by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. Columns. Yes. It went well. 6 problems. Do the abacus on the... Okay, right. So yeah. Yeah, the columns. Yep. So when we're looking, this is what it would look like. And then if you notice, I have a dot right here. This tells me that this is the ones place. Because I have the ones place over here, my next columns will be the decimal. After the decimal is my tenths and my hundredths. All right. So, yeah. When we're looking, okay, yeah, there we go. So notice that we have a whole set. The set is, we've done the 1, we've done the 4, then we got to do 3, right? So 3 is the same, it's a very similar concept. If I have 4 on the abacus, 4. I want to add 3. Now notice, what do I do to add 3? To add the 3, I know I have to add 2. The 2 has to come from somewhere. Why? To make a 5. So when we're looking, we have 2 from here. So we have to subtract 2 from the 4 to make a 5 with the 3. So this becomes 5, and my final answer is 7. What do? We plus the 5, take away the 2, so my answer is 7. 5 times 2? What about it? Cool? All right, we're going to do it again. We can do 3 on the abacus, 3 on the abacus. Guess what? We're going to add 2 to the bottom number, but we got to get it from somewhere. We got to get it from the previous number. So 3, take away 2 from the 3, and then add it to this 3. So now I've made a 5. So this is 5 plus 1 is 6. Hello, Shadow. And I know how to use it. Welcome back, Shadow. Welcome back. Thank you for joining. All right. And then we do it again. But notice, if I had 1 plus 3, right? If I had 1 plus 3, do I need to do it? No, I don't need to use I don't need to use a formula because I have enough. So always have to ask the question, do you have enough beads? If not, what do you do? All right. I think I'm about done. I can't keep my eyes open. Thank you everybody for joining. This is so crazy. I just got tired all of a sudden. So, thank you for the follow, Shadow. Thank you for the follow. All right. Yeah, I'm going to head out. Yes. Thank you everybody for joining. Thank you so much. I know, right? Thank you, Oblivia. Good night, everybody. Good night. Thank you so much. I hope you have a good... Oh, you too. Thank you, Scarface. I hope you too.
We are so glad you came. Bye-bye. 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 Bye-bye now. Bye. Bye-bye. Remember, please discard all candy wrappers and popcorn containers in the nearest trash receptacle. Thank you. Okay, bye-bye now. Bye-bye. Bye. Okay. Are they all gone? Is everybody gone? Huh? Good. Oh my gosh, my cheeks are killing me. I can't keep smiling like this anymore. I am exhausted. I think I need a break. A little break? Okay.
My next live will probably be tomorrow morning at about 6 Pacific Standard Time. 6 or 6:30 Pacific Standard Time. That would be my next one. Yes, E-Dub, you're right. There is a calculator on your phone, and you should use it. Keep your brain that way. Thank you, Michael. Thank you for letting me know that you're still here. But I'm going to head out. Thank you, everybody, for joining. Thank you, everybody, for joining.
Oh, and in case I don't see you, good afternoon, good evening, and good night.
All right. Have a good night, everybody. Thank you so much. Bye. I'm sorry, Shadow. I can't keep up right now. Have a good night. I know I'm sorry. I just can't do it. I'll see you in my next live. Bye.